All right, we're going to go ahead and get started. So today I wanted to do things slightly differently. Usually we just jump right into the topic, but I'm going to take 1 or 2 minutes to just introduce who Nogalis is, because I noticed there's some new faces in the registration that I haven't met before. So Nogalis is an Infor Alliance partner. We have been an Infor, and prior to that, a Lawson partner since early 2005 or 6, and we've been in business since 2003. We've been an Infor partner now for several years. And our business consists of 3 different areas. Our primary area today is our managed service area, where we handle the day-to-day workings of keeping the lights on with Lawson for a lot of customers. We do that for cloud customers and for on-prem customers, some going all the way back to 901, and most of them are currently on version 10 or 11, and just all the different kind of Infor products essentially, but mainly Lawson. And a part of our business is our consulting services. So that's basically implementations, custom application development, upgrades, and what have you. And a third part of our offerings is a set of products. One is our APIX data archive product for Lawson. We have a vendor management and vendor onboarding system called Vendor Launch, and our security reporting system called LSF-IQ. And there's webinars on all of those available on our site. If you go to nogalis.com/education, you'll be able to find all of those. And there's links to those products on our website, obviously. Our current clients are our MSP customers are mostly now Infor Cloud customers, where we handle kind of the day-to-day management of interfaces, any sort of customizations, doing reporting, handling onboarding and offboarding of users, that sort of thing. But we still have quite a few managed service customers that are on-prem. This is just a quick list of some of our customers. And our customers have shown a total reduction of 33% in cost of managing Lawson by hiring us to handle managed service for them. Our other services are basically, like I said earlier, we're a full service implementation shop, application consulting, custom application development. We do a lot of development for AWS serverless applications. So a lot of our customers have hired us to develop new applications for them in the AWS cloud. These are serverless applications, very exciting stuff. We do lots of integration services, and that's kind of what this webinar is about today. So you'll see a lot of that from kind of the best of the best, Desi. And we'll have web and mobile application development as well. And what's new in 2021? Well, mostly our web archive product, but not much else has changed. You know, we still are doing managed service, and we still work with a lot of awesome customers. And just to kind of give you a quick overview of our web archive product, for those of you who haven't seen it, I'm going to go ahead and play this quick video here. And after that, we'll get right to the presentation. This is a 90-second video, and I hope you enjoy it.
Are you maintaining a Lawson system for archive reasons only? Upkeeping an old ERP system for data retention can be difficult and costly. There's hardware and software maintenance and licenses, data center real estate and energy costs, backup, storage, disaster recovery, internal and third-party staff costs. You're also taking some big risks. Outdated components like WebSphere, Java pose security risks. Upkeeping old browser support is extremely cumbersome. User access gets more challenging each year. A simple hardware failure can wipe everything out in an instance. There's a much better way. APIX Data Archive by Nogalis makes it possible to migrate all your data to the cloud, provide your users with a simple, lightweight web interface, gives you the freedom to decommission your Lawson application servers forever. Step 1. We migrate 100% of your Lawson data to a cloud database. Step 2. We deploy our serverless solution. Step 3, we set up security for your users and provide them access to your data. Highlights: fully managed fixed-cost solution for data archive. 100% serverless with nothing to maintain or break. Satisfies even the toughest data retention requirements. Provide access to all your data in a way that is intuitive both to existing Lawson users and to those who have never used Lawson. Visit Nogalis.com to find out more about APIX Lawson Data Archive today.
Okay, it's up to me now. Good morning, everybody. I'm Desi Howes. I'm a senior technical consultant with Nogalis. Been with Nogalis for about 5 years. Been working with Lawson for about 10 years, doing system administration, installs, updates, custom development, and lots of IPA, lots of interfacing. So, as you may know, API offers a way for the two different applications to communicate securely with one another. And a lot of our IPA processes, a lot of our interfaces are starting to move towards using API to communicate with third-party vendors, sending Lawson transactions to the vendor or bringing transactions in from third-party applications. So today we're going to just go over the basics of making the calls, reading the responses that come back from the API. We'll briefly talk about how to trigger your flows, real time or near real time, and then we'll go over some real world use cases actually based on interfaces that we have actually written that communicate with API. Firstly, making the calls. There are two nodes in IPA that you can use to make your calls. There's the web run and the web service. Both of these, the basic authentication data can be set up in a configuration set. And I do recommend that because it will encrypt the password for you. Web service connections offer basic authentication and web service security. Both of those just accept a username and password. And then these web services make a SOAP call. So on the properties of the node, you'll want to select the configuration that has the web service connection. And just as a side note, this, like many of your configurations and your configuration sets, this can only be a one-to-one. So one configuration set can only have one web service connection. So what tends to happen is that your configuration sets will end up being logically grouped either by vendor or by interface. So in this case, we've got a configuration set for the vendor, and the SOAP location, that's going to be your URL for making the API call. And I use variables for that because oftentimes the third-party vendors will have a test area and a production area, a queue area, or whatever, and those URLs are changing. So I like to keep those in a configuration set so I don't have to edit the flow every time we want to change the URL. And then you'll select the action and the SOAP protocol, and those should be values that are provided to you by the third-party vendor, either in their documentation or they should give you sample calls. And the same thing for the XML, the input. You can get samples probably from the vendor or at least a template for how those calls should be set up. So that's the actual SOAP call that's getting sent over to the API that tells it what you're looking for, whether you're adding data or taking data out. If you go to the WSDL tab, the second tab, WSDL, that you can provide it with the schema URL. It'll be either a file that you have on your desktop, or you can provide it with an actual URL that points to the WSDL. And that's just a template. It tells this process how these calls should be set up. So all the calls should be included in that WSDL, all the available calls and what input they're expecting and things like that. So once you set that up on the WSDL tab, then you can click that build button on the general tab, and that will give you prompts and walk you through actually creating a call to get the data that you need. So I don't use the build button myself very often because, like I said, the vendors typically will give you sample calls, and I will create my own calls in an application such as Postman or Insomnia so that I can do like real quick testing. So those applications are meant to actually just call APIs. So that's what I use for my initial testing and proof of concept to see how the data works and what it looks like, how the API calls should be made. So by the time I get to my IPA process, I pretty much already have a fully formed API call. And so I'll just copy and paste it and then add variables as needed. The other node that you can use to make a call is a web run node. This can make calls via a query string. So you set up a web root in the configuration set, and your authentication types, the available ones are basic, again, so username, password, or the OAuth 1A. So there's different types of OAuth, and the only one this accepts is 1A, which requires a consumer key and a secret key, which you would get from your third-party vendor. And then, again, I would recommend putting this into a configuration set, but if you really don't want to, you want to set it up in the node, then you could click that override connection over there on the right-hand side and put all that same information that you put into the configuration set that can go into the override connection information. The URL type is going to be external because we're reaching out to something other than Lawson. The Infor Lawson URL type is for adding attachments or comments to like AP or whatever has a comments button. You can use that, or calling batch jobs. So, but today we're talking about actually reaching out to an external third party. So your URL type will be external. The web program is basically whenever you make your query string, like if you did it in a browser, it's basically anything that comes after the web root in that query string. And then the success string, normally I just leave it blank because most APIs, they'll return a successful or an unsuccessful response, but there's also other data in that response, maybe an error code or an error message, or the data obviously that you're getting back, or some kind of confirmation that it worked. And so I usually parse that myself. So I usually don't worry about having a success string. And then the header string, again, the vendor will let you know what needs to be there. Most common methods that you use are going to be get and post. So get is basically what it sounds like. It's getting data. It's pulling data in. So you're not sending data over. So there's no need for the post string. So that post string is disabled there. If you selected the method post, that would open up that window there to add the post string. And you would put an XML formatted or maybe a JSON formatted string of data in there that you're wanting to send over to the application. And we'll have a quick example of that later on. Reading responses. So whenever you make a call to an API, there's always going to be some sort of response coming back. It could be just a success or failure, but most likely it's going to have extra data in it, and you're going to need to parse through that data and do something with that data. So if you're getting, typically responses will come back in either JSON format or XML. So to read JSON, you're going to use a JSON parser node. And the input for the JSON parser is going to be the result from your web run or the output from your web service. And then if you go to the output tab, you can provide it with a sample document by clicking that sample document, and you browse to a document that you've saved off. So if you, like I said, if you run a test in Postman and get sample data, or if the vendor gives you a sample response from a request, you can put it into just a text file in a text editor. It can have whatever extension you want, and you add it as a sample document on this output tab, so that when you hit the set variable button, it will open up this handy screen that shows you all of the available variable paths to get to each element within the JSON. So this is based on the sample document that you provided. And you may notice that some of these elements have the brackets with the little number sign in there. And what that means is that that element can be recurring. So there could be multiple, it's a zero-based array. So there could be multiple instances of that element within your response. So whenever you reference those elements, you want to make sure that you're giving them an index. And like I said, it's zero-based. So the first record in that element would be 0. You would put a 0 in the brackets. And then there's the handy export variables button down there at the bottom that will take all of this data and put it into a text file for you. And that way you can copy and paste the variable paths and use them later on in your flow. It just makes it a lot easier. So the other type is a response is XML formatted. So to read those, you have a couple options. You could use an XML node, and your action on that XML node is going to be parse XML string. That's on the general tab. And then you provide it with the input, which is going to be your output from your web service call or your web run. And you'll notice here that this is not, this variable is not formatted the way IPA variables are normally formatted with the less than, greater than. It actually uses curly brackets. And you'll want to keep that in mind. Anything that uses XML, as you probably know, XML relies heavily on less than and greater than signs for the tags. And so if you tried to do variables the way that IPA normally does variables, your node is going to get very confused. What is this? Is this XML or a variable? So all XML nodes will actually use the curly brackets. So just keep that in mind for your variables. But it works just like any other node that allows variables. If you hit Control Space, it'll show you what variables are available. And once you select one, it'll put it in that correct format for you. On the schema tab of the XML node, you can provide the XML schema and the namespaces that are within that XML. And once you do that, when you hit the build button, it's similar to how the JSON parser works. It will show you what output, what elements are available and how to access them. So when you actually click on the element in that output tab, it will show you what the variable path should be. And then again, you can use that later on in your code. So if you are like me and prefer JSON over XML, another thing that you could do, you could convert your XML response into JSON. There's a JSON converter, and there are multiple options for converting things to JSON or from JSON. And one of those options is XML to JSON. And so I will often run XML through the JSON converter and then put the results from that into a JSON parser. And that way I can get my data, reference it the JSON way instead of the XML way. Because to me, it just works a little bit cleaner. For triggering for outgoing transactions, you probably know that you can, whenever some activity or action happens on a record in Lawson, you can set up a service that will kick off an IPA process. So in that case, that could be real time, right? So the service kicks off the IPA process, and then the IPA process sends that data right away to your third-party vendor. For incoming transactions, it's a little trickier to do real time. And we almost always try to do batch processing instead. And what I mean by batch processing is either the third-party API has a method, a way of like knowing what has already been sent. So you query the API, you get the data that you need, and then maybe you send some confirmation after it's been processed to let the API know that it's been processed, and then those records are flagged so that they aren't sent again. Another option would be maybe to use a date range. So that's basically how you do batch programming, batch processing rather. If it's really important to do real-time connections, like bringing in transactions. Let's say an employee was added to a third-party system and they need to be in Lawson in real time. You're going to have to get a little bit creative, and there's going to be some custom programming on the third-party system. Maybe the API could drop a trigger file that has maybe one piece of data in it that the IPA could use to make the call, and that would be used like by a file channel to kick off the IPA. You could get creative and create a work unit using the BPM processing to kick off the flow. Or maybe you can create a work unit by calling a URL. You can trigger flows via URL, but you got to get around the authentication issue there. So it could be tricky, but it could be done if really, really needed. So now we'll talk about our use cases. So this one is probably the most useful use case. I can see a lot of applications for reading tickets from a ticketing system over API, not just in the case of user deprovisioning, but obviously user provisioning would be great. The caveat there is a lot of the ticketing systems are highly configurable, and also role mapping can be real tricky to do programmatically. So you want to do a lot of upfront planning before you really start a user provisioning over API type of process, but it would be really great, I'm sure, highly useful. And then also just creating tickets. If a flow itself, if one of your interfaces fails or it notices that some process or system is down that should be up, you could just create a ticket rather than sending a bunch of emails to people who may or may not read it. You create a ticket and that ticket gets assigned to the person who should actually be working it. Calling a ticketing system, I can see is highly useful. In this particular case for the deprovisioning, it queries ServiceNow to see what if we have any users that need to be deprovisioned, and if we do, then it goes through, it deprovisions them in Lawson, deprovisions them in Landmark, and then it actually updates the ticket, closes it out, and puts a little description saying, hey, I did this and it was automated. And the important nodes on this flow are the web run, which gets the data, JSON parser. So this particular API happens to spit out JSON format, and then a bunch of assignment nodes using that JSON variable path, and then the web run post, which posts the description and closes the ticket. So I briefly described a flow, and then I show you a extremely cluttered flow because everybody knows that that's how they get. So this flow there's a lot of pieces to it, making a lot of updates to Lawson and Landmark, and then there's also error handling and notifications and things like that, and building archived documents and things. So that's why they always tend to get like this. So the first important node is the web run node that gets the data via query string. So it's running a get method, and then it sends over the header string the way that the vendor wants it. And then you've got the parser. So it takes the result from that initial call and parses it out into JSON format. And then you can access that JSON using the variable path that was provided. And you'll see that I have a for each. I'm using a for each loop, and that's what gives me my index. So like I said before, the JSON bar elements, if it's an array, it's an array. It's a JavaScript array. And the way that you find out how long or how many elements are in a JavaScript array is to do a length. So you can do the array.length, and that tells you how many elements are in there. So that's what I did. So I know how many records I got back. So then I can do a for each to loop through each record. And like I said, it's 0 based, and the for each starts at 1. So you just have to subtract 1 to set up that index there. And then one of the final steps is to update the ticket. And it again has a query string, sends a header, and then the post string. So it's a put, and the post string is formatted in JSON as the vendor wants it. And you'll notice that the variables there are the normal variables because this isn't XML, this is JSON. So the variables are formatted normally. And it just adds some notes and closes the ticket. So that's that. And then as with all of your flows, you should have error handling. I mean, this is just general stuff. Keeping a log of errors. If you're going to bypass the error, you at least want to keep a log of it so that you can notify somebody that something went wrong. Another use case is automating AP tasks. So we actually work with a couple of third-party vendors that do billings or claims and need to send vendors over, need to send check requests over, and things like that. The specific one I'm going to show you is a third-party billing application that creates contacts in their application. So they are the system of record for these contacts or vendors. And they get sent over, or actually Lawson reaches out and grabs new contacts as they're created, or it's a batch processing. So it doesn't get them as they're created. It gets whatever's new at the time, whenever it runs. And then it reads those in, it adds them, and then it sends a confirmation back with the vendor ID from Lawson. So that way this third-party system knows that the vendor has been created, and it has a link back to that vendor by the vendor ID. And same thing, it also sends over address changes. So that way we can keep those two sets of records in sync. The key nodes here for this one are a web service SOAP call. So that sends over an XML call to the web service and gets data back in XML format. So there is an XML node to read that XML. So again, it's a complicated process, but that's just the way they go. So it gets the new context, parses the response, saves that response, and then goes through each record and adds it to a file. I recommend, if you're going to be working with a lot of records, use the conversion jobs that Lawson already provides whenever possible. So in this case, it builds a file for the AP510. So it does an import DB into that conversion table, and then actually it runs the conversion job. So if you're only going to have one or two records at a time, then using Lawson transactions is fine. But it can be less efficient if you have a lot of transactions. And also, these conversion jobs are meant to kick out records that have error messages, and it's more efficient and it's easier to keep track of what was an error. And it also allows you to put things in, it'll put records in that were correct while it also keeps out the errors. So it just makes everything a little bit easier if you can use those conversion jobs. So this one is getting the data using the SOAP XML formatted SOAP call. And then here it's getting the response from that call. And then what it actually does is for archiving purposes, it saves the output of this XML node to a file. So then you've got an XML file that's fully formatted and in correct XML format. And that way you'll have something archived for later. And then I also use that file for parsing the data. And then again, there's a bunch of error handling. The top section is where it's getting new vendors, and then the bottom section is where it's getting address changes. So that's two separate calls. So you would need two separate web service nodes for that. For another use case that we have is for HR automation. So this is another one that's pretty useful. If your HR system is separate from Lawson, or if your time record system is separate from Lawson and you need to get some of those transactions into Lawson, or vice versa, if you need to send something out to another third-party application, it can be very useful. In this particular case, we have an expense reimbursement application that holds employee data, and we want to import those employees into Lawson as vendors so that they can be reimbursed out of Lawson for their expenses. And so the key nodes on that are the web run get. So this one allows you to use a query string, and it returns JSON, my favorite. And then the assignment nodes, as usual. So you're probably sensing a theme here by now. It's pretty similar. They're all pretty similar. So this one, actually, it pulls in employee records that are new based on a date range. And then this particular API is logically grouped. So there's different types of employee data. It's not all just brought back in one call. So you get a piece of employee data, and then you use that piece to make another call to get the next piece of data. And all the while building a record for that employee that you append to a file that's going to be imported, and again, run the AP510. So this is another one that runs the AP510 to bring in the vendors. So here's where we get the new employees. So we've got a date range here in the query string, and then sending a header, and the method is get. So that post string is disabled. And then parsing using a JSON parser to get the result from the web run. Again, you're probably starting to notice a theme. And then here is an example of setting a whole bunch of, using a JavaScript expression to set a whole bunch of these variables. So there's a lot of different JSON parsers that I had to use because, like I said, I've got to make multiple calls to different types of employee data. And then in a JavaScript expression, then I can set those variables, and then I can do things. I can manipulate them as needed within that expression. And again, this logs errors. This checks for errors that from the AP 510, errors from the AP or the import DB rather, errors that within. So if an employee errors out, we don't want to just kill the process. We want to just log that error and move on, and then send out a notification and saying something was wrong with this employee and a brief message of what was wrong. This also does check to make sure the vendor doesn't exist. If they already exist, then it doesn't update as a Lawson transaction rather than adding them to the AP 510 conversion. Finally, this is the last use case, sending bank transactions. So rightfully so, banks tend to be more strict with their authentication requirements with API. So this particular bank uses OAuth, but they require a certificate and a consumer key, and they want you to basically make a test call and bring back a very long ID to send back in the header for the real call. So web run and web service nodes can't handle all of that. So what I did was I wrote a custom program using C#, but I mean, get creative, use whatever language you're comfortable with. And all that custom program does is it accepts the payload file that I created in IPA, and then the output of that custom program is the response. So that I call the custom program in a system command node, and so the output of that system command node is the response of the XML response from the bank. So there's the XML node to build the payload, and then the system command node to run the program, and then you can parse the response from there. So this one, the first node, the submit payment request is the first one that's important. This is actually, you'll notice the action is not parse XML object, it's build XML object. So you'll put all of your XML in here and build the object, so it'll put it in the proper format, and IPA will recognize it as XML, and so will your custom program. And then just as an aside, you'll notice the description, the variable for the description has the curly brackets. So that's something I just want you guys to be aware of and keep in mind, that this is XML, so the variables need to have curly brackets. So this builds the XML, and then the output of this XML builder I put into a file, an XML file, and then that way I can just send the custom program the file name, the file path, and it will take the contents of that file, send it over to the bank, do all the extra security stuff that it needs to do, and then give me back a response. And then that response is actually what I parse. And this is an example of parsing from XML to JSON. So I run this through a JSON converter from XML to JSON, and then I run that through a JSON parser to get the data out that I need to send users, to let them know what happened and what the IDs were that came back from the bank and so forth. So this one's actually less cluttered, probably because much of the work is actually done in the custom program, but it also wasn't a very complicated ask. It's just a complicated API. So that is the last one I had. So now I guess we would take questions.